Let's look at the most common mistakes for each topic of AS, physical chemistry. So the first that we look at is atomic structure, where electronic configuration, mass spectrometry, and isotopes. Okay, most of you at this point might have forgotten a little bit the mass spectrometry. Okay, so yeah, important topic to revise. In terms of atomic structure, so I would say the most important thing that you need to remember is the how to write the electronic configuration. I would suggest you always to look at the periodic table. Okay, so make sure you are confident with the periodic table and how to work out the electronic configuration from that. I would say the most important thing is the exception of the alpha principle when you do the electronic configuration of transition metals, and in case of the explanation, which is the stability of the d orbitals. Okay, this is the most common mistake. And if you don't remember exactly why that occurs, well, remember that the 4s2 is before the 3D, okay? And well, we can, remember the rule, but also we just see it from the periodic table, okay? As long as we remember that this part is I'm gonna put the spotlight on actually. As long as we remember that these, is the 3D, okay? And then remember that everything in 4, D4 and D9 will have this exception because of the stability of the d orbitals, which is prioritized over this alpha principle, okay? That's important. Mass spectrometry, easy to forget, but you must know it for organic analysis, the very last topic that you do, together with the NMR, because in the last topic you study NMR, but the exam questions are very likely to have something about the mass spectrometer for first. Okay, so important to remember the instrument. In AQA, you need to do the calculation of the time of flight. Trust me that it's going to be in the paper, 5 marks, okay? If it's a simpler calculation, 3 marks, but I would highly suggest you to keep it revised, okay? If you don't, there will be one question in the exam paper anyway, but remember the unit conversions and the key equations involved, kinetic energy, how to find the mass in kilograms of one atom, and then how to calculate the velocity. Okay, so that's the calculation of time of flight. Mass spectrum of molecules. So even though it's stated for just AQA and Excel to know, it's a very common multiple choice for any exam board, really, where you have to, work out the mass spectrum or just do some. I'm not sure the type of question that you could get, but explain the different peaks, for example, or suggest why there are so many peaks. Just be aware of what the mass spectrum of a diatomic molecule look like. Okay, and taking a step back, the calculation of the AR, relatively simple, unless you need to do the quadratic equation calculation, or not quadratic equation, but you have an algebraic equation to work out. Okay, so trust me that these calculations can get tricky. So there is some extra content on the classroom for the specific calculation, the more challenging one. So I would invite you to look at that if you don't feel confident in it yet. So bonding, common mistakes and difficult type of questions. So we're revising the basics is very important, okay? Because if you don't know how to describe bonding at this point, well, take a moment to go back and look at it, okay? Because we should be very confident with all of the type of bonding, with all of the type of structures, describing all of the structures, okay? That's important. I don't want to revisit them anymore. Now, the important topic that you will see a lot in organic chemistry as well, you need to apply, for example, in the topic of alcohols, but actually essentially is a very important topic for everything else, the concept of electronegativity. It's common to forget the equation and the trend. Okay, so I would suggest you to remember the trend actually not just of electronegativity, but of nuclear attraction across the whole periodic table. If you remember that, then all the other trends will be a lot easier. Okay. Common mistake is the polarity and not recognizing when a molecule is polar or not. And this is actually, where did I see this? Oh, in the isomers of transition metal topic. Yeah, same concept. You need to observe the direction of electron density. Okay, if it's spread all over, it's a nonpolar. If the electron density goes in just one direction, then it's going to be a polar molecule. Okay, so get confident with the symmetry for, well, we have it in this topic, but also for the shapes, the symmetry is quite important. Okay, and we will see that in advanced organic chemistry as well. Okay, so polarity in alkenes. Okay, that's important in E and Z isomers. So the first important thing, actually one common mistake to do here is that, let's say you have this question, predict which of the following molecule is polar, and you try to work it out like this. That's the first mistake. If you can visualize it, yeah, you must visualize it. So write down in this case, the displayed formula would be very useful. Okay, so that's one common mistake, not writing down the formula of molecules. Okay, forces, I hope you have cleared the basics of each forces. A very common mistake is in the hydrogen bond. When you don't recognize that hydrogen bond is just when the OH bond is present, okay? For example, aldehyde, which has a structure carbon double bond O, but without the OH, doesn't have hydrogen bond. Carboxylic acid has, because it has this OH, okay? Is a mistake that I've seen happening just because it's because we don't have the displayed formula or we cannot visualize the structure of the molecule. So make sure you do that when you do everything. Okay, effect of intermolecular forces. Just make sure you can describe you recognize the strength of the different forces. And you know what is common mistake is when you have a bit more open question that you have to compare the forces. And for example, if a molecule has hydrogen bond, you don't mention the London dispersion force. So remember that you must mention it for any molecule, okay? And then you can do the comparison of different forces. And one common mistake on the London dispersion force actually is to forget the trend of it, or why is it stronger. Okay, remember that the more electrons, the stronger the force. So if you have to explain it, you have to say because it's a larger molecule, or because it has a higher molecular mass or relative formula mass, or more electrons. Okay, anything related to the factor that affected this force. Okay, shapes. One common mistake is to not write down the dot and cross diagram, okay? Because to work out and to explain anyway the repulsion, I think you kind of learn it, because the repulsion of lone pair is greater than the rest. So this is really how you're asked to write it in the mark scheme. But to work out this shape, you must have clear how many bond pairs and lone pairs are present. And very often they explain it in a complicated way that is you need to count the electrons of one atom, count the electrons of the other atoms. Forget it. Just write down the dot and cross diagram because it takes less time than doing the counting of electrons. And then you will see straight away how many lone pairs and bond pairs there are. Okay? So this is the common mistake, to overcomplicate the shapes. Okay. And then, well, remember that if you're asked a shape, it's very unlikely that it's going to be a simple one. So it's likely to be a more complicated molecule. So in the exam practice, we will have a look at that. Okay. Bond strength, I would say it's more of a basic concept that you must have clear in order to explain, to compare melting point and boiling point, but also to in more advanced topics like the enthalpy, where you have to explain why the lattice enthalpy of one atom is it's higher or more exothermic, okay? But so this is a basic concept that we will see in A level a little bit more, okay? So this is bonding. Let's go into the next lesson, which is amount of substance. I'm gonna take a break to breathe in. I drank too much coffee this morning, so I'm actually really thirsty with water. In the meantime, is there any question? Do you understand the point of the of this? Am I going too fast, or is it all okay? If there is any issue, please text now in the direct messages. Otherwise, I'm gonna continue. Okay. I'm guessing is all okay. Oh, I'm actually still recording, don't I? Okay. So I think there was something wrong with the recording. So I'm probably still recording. Okay, anyway, we're looking at the amount of substance topic. Okay, again, I'm going to scroll through very quickly. Ionic equations. Common mistake is not remembering how to do them, in the sense that you don't remember the two different approaches, okay, which is either you cancel out repeating ions, and actually, yeah, here is the common mistake, that you split covalent compounds and solid ionic products and elements, okay? That's a common mistake. So for example, in this example where you have water, H2O, just the covalent molecule, that you're not going to write as H plus and OH minus. But you know where is this common mistake coming from? Is that you study in A level the acid, like the acid and base topic, where you see that water actually does dissociate into H plus and OH minus. So it's a common mistake. That's why we needed to make sure we remember this rule just for the for writing ionic equations. Okay. Ratio. Okay. At this point, I think all of you are confident in discussing moles ratio moles. So I think you always remember it. It's easy to forget it in calculations like the empirical formula, where you actually do moles, and then you have to find the ratio. Okay, but as you can see, these three steps are recurring in pretty much all the calculations. So the most common mistake for any type of one very common mistake when you do the particles calculation is you don't read the question properly, and you miss what you're asked for, because very often they don't ask, calculate, like you have, chloride or, a molecule, calculated the number of atoms. It's more difficult. Maybe you have an ionic compound and you're asked to calculate the total number of ions. Okay, that's a little bit more difficult. Okay, so for example, in this case, you have, yeah, that's exactly the example. Find the number of ions in KCl. But KCl is made of 2 ions, so that's what you need to recognize. Okay, so when you have Avogadro's constant calculation, very often comes as a multiple choice. Make sure you read the question carefully to understand if you have any ratio that you need to work on. Masses should be, I think, okay. Just check the units. Concentration, conversion, okay. Always notice the unit. You have them written right there in the question, so you just needed to read it properly and notice the unit, okay. So when I read this question, for example, the units, they really are highlighted, as I read it, so I know that I have to do the conversion. Very important, okay. Then back titration, well, that's just, we need to practice it more and more. Okay, I've been looking through some past papers, and like calculation or RTP, you needed to recognize when to use it. Of course, that's important, because sometimes it's like very clear when you're given the 24, then it's that, but sometimes you're not given that and you're just given room temperature and pressure. Remember the molar gas volume. But actually the common mistake that I wanted to highlight was with the ideal gas, okay? The equation is relatively simple, easy to remember, but the conversions can go wrong. And then there is another very mistakes that is super easy to mix. But let's look at the conversions first. I'm going to stick here. I would suggest you to remember one combination of units, okay? And then just do the conversions from there. For example, when you have the pressure in pascals, your volume is in meters cubed. When the pressure is in kilopascals, your volume is in decimeters cubed, okay? Remember one of this combination, okay? And then just do the conversion. It's going to be easier, okay? Because I think you should be confident with this now. And most of the time, you will have to do conversions anyway from centimeters cubed, okay? So just notice the unit once again. And then, temperature in Kelvin. You cannot forget to do this conversion because you're always given the gas constant with the unit. And if you notice the units, they will have to cancel out to give you whatever you're calculating. So notice them. Okay. Let me see this question very quickly. Okay, this is pretty straightforward. But sometimes in the gas equations, you have a question where you have an equation and you're asked to calculate the total number of moles of gas. And you might have to check the product if you have more moles product. Okay, I hope you understand what I mean. Because sometimes you calculate the volume or the pressure of something that you're given the moles of. But what if that's a solid? Okay, you would just use that amount of moles and do the calculation. But then you don't realize that you needed to calculate the gas. So make sure the moles that you use are relative to the gas in that specific equation. Okay, so notice the moles if that corresponds to the gas or to a solid product. Okay, careful with that. I've seen this mistake very often. Okay. Percentage yield calculation relatively straightforward. Sometimes you are asked to calculate the theoretical or the actual yield instead. Make sure you know how to rearrange it when you have a percentage, which I would suggest you to just divide everything by 100 and then do the rearrangement a little bit easier, okay? And then in the interpretation of the question, make sure you distinguish the actual and the theoretical yield, okay? You need to read the question very carefully because the hints are all in the question. So, for example, if the mass of copper chloride produced that's the actual yield. So something related to, it's formed, produced, prepared, or obtained, this all refers to the actual yield. So make sure you notice these keywords. Okay, atom economy, I think it's relatively simple compared to the others. Empirical formula. There are some calculations that are actually very difficult. So first of all, empirical molecular formula calculation, fundamental for this very open question on NMR, okay? So you must be 100% confident with this. But if you have a standalone question of empirical formula or molecular formula and molecular formula, they're going to be a bit more challenging, okay? And very similar are the water crystallization question. At the end, it's really the same. And this is the calculation where I was saying that you have moles, ratio, moles, but this time you find the moles of the two things and then you find the ratio. Okay. However, sometimes you're given the, for example, the combustion products, and you have to find the empirical formula from that. Okay, so here requires a little bit of logic, and you need to be confident with or just interpret that somehow you need to get to the mass of one element specifically. Okay, but we will go through some exam questions so that you understand what I mean. Water of crystallization, very common second part of the calculation in back titrations. Okay, so at the end, the calculation is very similar to the empirical formula. At some point, you're going to have to find the ratio. So think about that when you interpret the question, okay? And I think that is it for the amount of substance. And I'm gonna now go into the second section, okay, which is the energetics rate and equilibrium. So the topic of energetics, entropy, Hess's law, calorimetry. Very, very important for A level because it's the foundation of thermodynamics, and the more complicated cycles that you study are really the same concept as Hess's law, just with more equations. Okay, so the most common mistakes that I see in Hess's cycle is forget how to do the cycle. Okay, what I would suggest you to remember is just the general cycle, okay? This ABC cycle that you can apply then to any cycle that you have, okay? So also, if you just memorize the formation combustion equation during the exam, I think you can, I think it would be very easy to forget, okay? Because it's just these illogical products minus reactants, reactants minus product. I would forget it if I was in a little bit more anxious moment. So it's much easier to interpret the definition of formation and combustion and then work out this theoretical cycle. A, B, and then a C is your common, okay? Common elements for formation, common combustion products for combustion, okay? Because in this way, I think you can construct any type of cycle, even if it's a different one that you don't have combustion or formation, but maybe is, for example, here we have an example. And we don't. Anyway, if we have another cycle that you have an intermediate instead, okay? Just try to do always this ABC cycle when you have an Hess's law calculation, okay? It would make it faster and you can, be confident with the equation that you do. One common mistake in this topic is with the bond, not the bond enthalpy itself, because the calculation is relatively simple, but if you rush it through, it's very easy to miss out, on some of the bonds, okay? So I would always suggest you to write down the displayed formula, as long as then you don't get that wrong. So double check it, okay? And then make sure you count them carefully. If you do it, I would say always slow it down when you do this calculation, because it's so easy to miss. Second mistake is is in the sign. Remember that the sign, of course, is super important for the enthalpy calculations, because it would determine if it's an exothermic or endothermic reaction, okay? So double check that. And another common mistake is, I've seen some question where you have to discuss why the explaining why is endothermic or exothermic, okay? And the reason is always relative to the bond breaking and bond making. So the exam question would be something like, explain why the reaction is exothermic. Okay, we would think, oh, well, because it releases energy, but that's not the point. Whenever you have this type of question, you must mention it in terms of bond breaking and bond making. So will always be, for example, if it's endothermic, you would explain it as because the energy required to break the bond, it's greater than making the bonds. Okay, this is what the mark scheme wants. Yeah, I'll let you absorb this for a moment. Calorimetry. Equation, I hope you remember it. Common mistakes. The mass, you must use the mass of water or the mass of the substance that is changing temperature, okay? If you write a change in temperature, make sure you use the mass and the specific heat capacity of the substance that changes it. And then a common mistake is also forgetting that is in joules. Okay, because, well, I think if you're given a specific capacity and the unit, once again, observe this unit if it's already joules or kilojoules, because this is then what determines the heat. And then, well, to calculate the enthalpy, we know that we need to convert it into kilojoules per mole. So divided by 1,000, not 100, oops, mistake, and then divided by the moles. So a common mistake is also not recognizing the moles of what. For example, if you look at this question, combustion of 2.9 grams of hexane changes the temperature of 200 grams of water. So in the specific heat capacity equation, you will use the mass of water. Okay, while in the moles, you use the moles of the substance that, the equation, or, well, the substance that you want to calculate the enthalpy of. Okay, very important. And I'm going to say something else. Okay, we will see anyway some exam question where these come in a little bit more complex question. Actually, a very common question that comes after is to calculate the or explain the heat loss, or how the heat will be different if one of the experiment like one of the steps in the experiment is different. So you have to think about, like, logically about the like the heat, if there is like more heat in the reaction, less heat in the reaction, and the effect that this would have on the enthalpy. Okay, so there is some logic here. We will see some questions. And in terms of how to improve the experiment, and let's look at the diagram, how to improve the experiment and the sources of errors. Remember the instrument itself, loss of energy, using a lead, maybe using a digital thermometer. Okay, so this is general for all of the experiment that you have to improve, looking at your equipment, if you can have an equipment with higher resolution. Okay, actually, one point that I've seen in these more complex exam questions is, let me show you here. Here we're actually we use the mass of water, which is here already given as a mass, but sometimes you're given it as volume, and you might be given the density. So you need to check if the density of the substance that changes temperature is 1, or you have to do an extra calculation there. Okay, so that's why you would be given the density. Very important, because I know if we see a number or a term in the question that we are not familiar with, it can throw us off. Okay, I hope it's all clear, and that's all for the energetics one. Okay, the next one is rates. Okay, once again, if there are any questions, if there are any questions, please let me know. Otherwise, I will continue. And okay. So for the rate, in A level, you study kinetics, okay, which is of course the more advanced topic. But there are some key concepts here that you have to apply to that. To any explanation that you do in terms of kinetics, okay? Very important. So it's all about the collision theory, okay? So don't forget that whenever you have to explain like changes in rate, you do have to explain it in terms of collision with enough energy to overcome activation energy, and also correct orientation, okay? And, well, factors, I hope they're clear for now. And one common thing that we forget is the investigation of the rate. Like, you always need to consider what variable you can observe, in the reaction. Okay, for example, a change in pH would require titration, and that corresponds to the change in concentration that then you can plot to find the rate. Okay, hope you understand what I mean. So whenever you have a rate question, and if it's asked about the investigation, just make sure you observe the reaction and you look at the variable that can be changed. Okay, gradient, Boltzmann distribution curve is just in AS really, so I hope you remember what it's all about, because it should be an easy question if you're confident, but using the correct terminology about the proportion of molecules that have, enough energy to collide or more energy than the activation energy. So make sure you use these keywords when you describe it, and then kinetic energy. Catalyst, very important. Remember, lowers the activation energy. That's how we show it in the Boltzmann distribution. Okay, so it's common to get confused, and I hope it's okay with catalyst. With catalyst, I would suggest you to remember one example for homogeneous and heterogeneous. When you do transition metals, you will study more of actually you study both homogeneous and heterogeneous. So it could be worth it to have an example from the topic of transition metals. Okay, just so you have showing one thing. Okay. And that was it for the rate. It's actually short topic respected to the others, but still very important foundation for A level. And lastly, and that will be it for the physical chemistry, is the topic of equilibrium. Very, very important. So this is big foundation for the whole KP topic for A level, but also the acid-base, topic, which has, the very massive one. So, Le Chatelier principle, you must be confident in describing the changes, okay? Because it's a question that does come up, maybe not as a whole question. In a yes, you could have more open questions with discussing the factors that affect the position of equilibrium, as well as the compromise in like temperature and pressure. But in A-level papers, this is very likely to, maybe 1 or 2 marks after a bigger calculation, okay? And the most common one is the effect that pressure, temperature, concentration have on the K value, okay? So this is very important to not remember, but just that you're able to discuss logically, okay? And okay, units, make sure you work them out by canceling them out. Don't rush it through. If you can write it down in the paper, and work it out, is just better. And the important part is in the calculation of the equilibrium constant, okay? So here it's not in this note because it's actually in A level, but for AQA is also in AS, but how to calculate the actual, equilibrium moles, okay? And here I will put a link to the explanation video, but that's a very important calculation to do. And I would say normally everyone is kind of okay with this. Common mistake is not realizing that it's KC, so it's concentration, not moles. So if you have a volume, notice the volume, and you need to do the extra step of finding the concentration. Okay, and I think that's it. But we will see now some exam style questions that are going to be, they're going to really challenge these topics, and you will get the chance to see where the common mistakes are. Okay.